Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Gravitation. Any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify the doubts in the subsequent videos, and also in any other chapter of physics. If you have more difficulty, then please write the name of that chapter also in the comment section, so that we can give more priority on it and solve more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application, whose link has been provided in the description. Here it is told, if m is the mass of the earth, so m is the mass of the earth and r is the radius of the earth, the ratio of gravitational acceleration to the gravitational constant is. So we know that mass of any object, or the weight of any object on the earth of mass m, its mass is m, so its weight will be mg. So mg will be equal to the gravitational force, which is g m by r square. So therefore g is equal to gm by r square. So therefore the ratio of gravitational acceleration and the gravitational constant, which is g by capital G is m by r square. So option 2 is the correct answer. Then it is told, the moment of inertia of a rigid body about an axis depends on the uh, position of axis of rotation. It does not depend on its mass. It depends on its size. It does not depend on its size, does not depend on its shape. So B, D, and C are wrong. Also depends on the it depends on its mass also, size also, and shape also, and it also depends on the position of axis of rotation. Position of axis of rotation. So option A is the correct answer. Then it is told, when a planet revolves around the sun, in general, for the planet, kinetic and potential energy of the planet are constant. No, that is wrong. Linear momentum is not constant, and linear velocity is also not constant. Angular momentum about the sun and areal velocity of the planet are constant. So this is true. Option B is the correct answer. Two bodies of masses 8 kg are placed at the vertices A and B of an equilateral triangle ABC. So here we have an equilateral triangle, suppose. So on the vertices A and B, 8 kg masses are kept, 8 kg. A third body of mass 2 kg is placed at the centroid G of the triangle. At the centroid 2 kg is placed. If AG equals to BG equals to CG, yeah, of course, these three lengths will be same, and these lengths are 1 meter. Where should a fourth body of mass 4 kg be placed so that the resultant force on the 2 kg body is 0? So it means that here the resultant of these two forces, the so we have to find the resultant force on the 2 kg object. So here the resultant force of these two forces should be F and F, suppose F1 and F1, let's say. So F1 will be equal to G m1 m2 by r square, equal to G into 2 kg into 8 kg by r square, which is 1 meter whole square. So it is equal to 16G. 16G Newton, I can say, okay. And the resultant of these forces will be, so this angle is 120 degree. It will be, so their resultant will be along this only. Hence, the resultant will be along CG only, since they are same force. So the resultant will be along the angle bisector. This is the resultant force of these two forces, and its magnitude will be root over f1 square plus f1 square plus 2f1 f2 cos 120. So 2f1 square cos 120. Cos 120 means minus half. So this will be equal to f1 only. So resultant force is also f1. So how much should, where should the 4 kg be placed? 4 kg should be placed somewhere here at a distance of r from the 2 kg object. So on the point on CG only it should be placed. So it means this force also should be F1. So F1 should be equal to G M1 M2 by R square. This should be equal to 16G. So G and G will cancel. So 2 4 is 8, 8 2 is 16. So R square should be equal to 1 by 2. So R should be equal to 1 by root 2. So if it is point P, then the length PG should be equal to 1 by root 2 meter. It means the 4 kg mass should be placed at the point P such that the distance of the point P from the center at G should be 1 by root 2 meter. So option B is the correct answer. Then it is told electric as well as gravitational effects can be thought to be caused by fields. Which of the following is true for an electrical or gravitational field? Fields are useful for understanding forces acting through a distance. There is no way to verify the existence of a force field since it is just a concept. The field concept is often used to describe contact forces. Gravitational electrical fields does not exist in the space. No. Okay, so here field means the gravitational field means the gravitational force per unit mass, and also electric fields also means the electric force per unit charge. So it means that if unit charge means 1 coulomb charge is placed at a uh, did, at a at some point P, so then how much force any system of charges will exert on it. So that will be the electric field due to that system of charges at that point P. Similarly, suppose if you take unit mass means 1 kg mass at some point P, and if you take a system of point masses or a continuous system of masses, and it exerts some force F on this mass of 1 kg, so then this force will be equal to the gravitational field due to this system of masses at that point P. So it means fields are useful for understanding forces which are kept at a distance. So option 1 is the correct answer. So hope all of you have understood all these concepts, all the solutions of these questions. Still any doubts if you have, then please write that in the comments section. And please install our Sapience education application also, since we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.